to get back to doing the SAT practice test number 8. We're in the calculator section, and last time we finished 25, so we're moving on to 26. Alright, 26. To determine the mean number of children per household in a community, Tabitha surveyed 20 families at a playground. For the 20 families surveyed, the mean number of children per household was 2.4. Which of the following must be true? So we want true things, not false things. Got to pay attention to that. Mean number of children per household. Now, she went to a playground. Do the people without kids go to the playground?
No.
Only if they're creepy. Not that one. B. A determination about the mean number of children per household in the community should not be made because the sample size is too small. In a sample size, usually you want 30 or better. Anything under 30 is considered a small sample size. However, not only is the sample size too small, but these people weren't randomly selected. They were chosen because they were at the playground. So maybe, but I don't like it 100%. C. The sampling method is flawed and may produce a biased estimate of the mean number of children per household in the community. Sampling method means I just picked people at the playground. I didn't go knock on doors in the community. I didn't randomly select people. So far I'm liking this answer. The sampling method is not flawed. I don't like that. It certainly seems flawed. And is likely to produce an unbiased. I think it produces a biased one because people without kids are probably not at the playground. So let's go with C. Alright. Number 27. In the xy plane, the point PR lies on the line where the equation y equals x plus b, where b is a constant. The point with coordinates 2p, 5r lies on the line with the equation y equals 2x plus b. If p is not equal to 0, what is the value of r divided by p? Alright, so this line is on this equation. This is the x part, that's the y part. So I can put those in there. So that means 5r equals 2p plus b. It's kind of ugly. I put the 2p where the x was, I put the 5r where the y was. Now this part tells me that this point is on that equation. So I'm going to go ahead and put those in there. I'm going to put the p where the x is, and I'm going to put the r where the y is. So r equals p plus b. Now, this top equation, I need to clean this up a little bit. I can distribute. So I have 5r equals 4p plus b. Now what I need to do, I need to get something that looks like r divided by p. And I've got two equations. I need to get one equation. So I'm going to subtract this whole bottom equation from the top equation. So 5r minus r, I get 4r. 4p minus b, I get 3p. And my b's are gone. So now I just have r's and p's. We're getting it. I need to get r divided by p. So I'll divide by p, divide by p. So 4 times r over p equals 3. And now to get r divided by p by itself, divide by 4, divide by 4, and my answer is b, 3/4. The 22 students in a health class conducted an experiment in which they each recorded their pulse rates in beats per minute before and after completing a light exercise routine. The dot plot below displays the results. So we've got before, we've got after. Let S1 and R1 be the standard deviation and range respectively of the data before exercise, and let S2 and R2 be the standard deviation and range respectively of the data after exercise. Which of the following is true? Alright, so standard deviation is often just sigma. Without getting into too much of the details, it's mainly telling you how close the data is to the center. And your range is your biggest minus your smallest. So let's look at the range here. It went from 56 to 88. So you've got a range of 32 here. It went from 80 to 112. So you still have a range of 32 there. So the ranges are the same. But if you look, the beats per minute before, most of your stuff's right here in the center. And after, it's all spread out. So that means after is going to have a much bigger standard deviation. So standard deviations are equal? No. S1 is smaller? Yes. But R1 and R2 are going to be equal, so that's not right. S1 bigger? Nope. This one says S1 and S2 are not equal. Not equal means could be bigger, could be smaller. Both are true, according to not equal. And this is going to be bigger. Bigger counts as not equal. And it does have the ranges as equal, so this one's going to be D. The photocopy machine is initially loaded with 5,000 sheets of paper. The machine starts a large job and copies at a constant rate. After 20 minutes, it has used 30% of the paper. Which of the following equations models the number of sheets of paper, P, remaining in the machine n minutes after it started printing? Alright, so this is our starting point. So that number needs to be by itself. So these are exponential looking models. These are linear looking models. Linear, exponential. And it does it at a constant rate. Constant rate is basically screaming that it's a line. If the rate's changing, then you need something other than a line. But constant, it means it's going up, it's going down, whatever. That's constant. So 20 minutes, it used 30% of the paper. And I want to know about m minutes. 30%, before you can do anything with a percent, you got to make it a decimal. So I move the decimal over to 5,000 times 0.3. But we get to use one in this section, so whatever, might as well use it. Alright, so this gives me 1,500. Now, that's after 20 minutes. Now, we need per minute, because in here we have m, so it needs to be for each minute. So now I'm going to take, my slope is actually going to be the 1,500 divided by how many minutes, which was the 20. Divide 1,500 by 20, I get 75. So this one, I start with 5,000, and it's going down 75 per minute. So B is going to be your answer. Alright, we'll pick it up next time on the next video.